Everybody do their homework?
Yep. What's that?
What's that? Actually ran into that this morning. I was grading senior seminar stuff, and this one assignment, the student turned it in 3 days late, and basically it looked like they had just blown their nose in the assignment. And they had like a week to work on it. I mean, is that even worth partial credit? These are seniors.
That's why it's not worth partial credit.
If that's even possible. All right. So last time, let's see where we left off. I think we have we have one of our actors. Well, we actually have an actor blueprint, and we have two instances of our actors here, right? And each of these instances has their own timer inside of it. The timer says we're going to do something for 20 seconds. And inside that loop, inside that repetition, so this says do something for 20 seconds where inside of our game loop, we're probably executing some maybe 25 times a second, something like that. We're going to be changing our Y position to some random value of, well, what it currently is, plus a random number between 3 and 9. So we should be able to see our two guys competing with each other. Now, what I'm going to do is I'm also going to display some text, and we'll put it above our timer. It probably didn't make any difference here. So I'm going to display the actor's position on Y value so we can actually see it as it's increasing. Okay? To something dark. There we go. Okay. Hold on. Everybody relax. This isn't going to get me what I want you to see. I need to... just take the floor of it. All right, so I'm going to use a function called floor, which should just truncate it. So if it's 2.75, it'll just be 2. That way I can just see a hard-coded Y value instead of seeing all the decimal places after it. I think this should do what I want it to do. Okay. Now, what if we want to know how long the race is taking? We're going to go ahead and we're going to create another actor. So I'll add an actor. We'll call this guy Clock. And the clock is going to have a timer as well. He's going to do something for 20 seconds. And we're going to add an attribute to our clock. We're going to have it be an integer. And we're going to call this guy countdown. And we'll start countdown at 20. So actually, instead of doing something for 20 seconds, we're going to do it for countdown number of seconds, which initially will be 20 because that's what I set it as, okay? And what are we going to do each time through? We're going to change an attribute. The attribute we're going to change is our clock's countdown, and we're going to change it to whatever it currently is minus 1. Okay, and then we're going to go ahead and have our clock display the current countdown so we can see how close the race is to being over. All right, so we built that blueprint, but now we need to actually put the clock out on the screen, and we'll resize it a little bit here.
You forgot to set every 1 second. Yeah, you can have every countdown second.
Oh, thank you. Well, actually, this is an interesting, of course I did this on purpose. Let's run it again. What does this say? This says do something for 20 seconds. And what does it say to do? Display countdown -1. So it did countdown -1. Why isn't it changing that attribute? Okay, well, I'm inside this loop, and this loop says each time through, do something for 20 seconds, change the countdown to the countdown -1. How long do you think this takes? This one instruction here. Like, hardly any time, right? It's almost instantaneous. Well, why isn't it bouncing back up here?
You have to run to completion.
You want to hit run to completion? What's that do? Well, let's look at it. Change attribute is something called an action. What, oh, change me back. That'd be really funny if they had some like really questionable. Okay. Notice that this guy is something called an action, as opposed to I think display text. Is that a behavior?
Mm-hmm.
Yeah, display text is a persistent behavior. So display text is doing something over and over and over and over and over again. Now, I think if this works, then I'm right. If it doesn't work, and I was just showing it to you on purpose as a lesson. It's like, what does that even mean? How am I going to do this? Okay. I'm actually trying to decide how I can even prove this. All right, I'm going to display text inside my timer. The text I'm going to display let me do this. I'm going to create a rule. So I'll ask a question inside of here, and we're going to say if an attribute, which attribute? The countdown attribute is currently equal to 20. Then what we're going to do is we're going to display it We'll display it in black. And then we'll change attribute. Countdown is equal to 19. Else, display text our countdown and set it back to 20. So this should toggle back and forth between 19 and 20. So we'll display our countdown. And then we'll change attribute of countdown back to 20. Okay, and I think this is going to work the way I want it to work. I'm going to take run to completion off. So this is going to do something for, just for the sake of argument here, let me set that to 20 seconds. So this is going to do something for 20 seconds. Each time through, it's going to ask a question. I believe when we ask the question, it becomes a persistent behavior. So we're going to do something for 20 seconds. Each time, we're going to ask a question. What are we going to ask? We're going to ask if the countdown is currently 20, display it, set it to 19. Otherwise, display it, set it to 20. So this should toggle back and forth between 19 and 20. Okay? Now, changing an attribute we looked at as an action. It happens one time. But I believe since we've wrapped it inside of a rule, it will become a persistent behavior because this rule will get executed each time through. I think that's going to be the case. So clearly I'm showing you a lesson here. I did this on purpose. Another rule of the matrix, I guess. Okay, so it looks like our fix for this then is going to be do something for 20 seconds. What are we going to do? We're going to create a timer to do something every 1 second. And what are we going to do every 1 second? We are going to
Change the attribute. Display the text.
change attribute. Countdown to be countdown -1. Okay. And then what we'll go ahead and do is we'll display the text outside of that timer. So we'll understand how a persistent behavior works. So I'm going to display the clock's countdown just as part of the game loop here. Okay, so this is a single time, this isn't inside the timer. But display text is a persistent behavior, which means whenever the state of this variable changes, so will what the text that's being displayed will change as well. I don't need to have it inside of some timer that says, okay, after I update it, now display it. Okay, that's why I did not put it inside the timer. So this timer says for 20 seconds, change this by -1 every 1 second. Again, I used white text, but I did that on purpose. Oh, it was tie. So we gotta go to the photo finish. We have to untruncate those numbers. And how many decimal places do we go out to determine a winner? Okay, so it kind of makes sense. How can we can come up with loops? Now something that's interesting here. So we just ran that for. I'm going to run this one more time. This might not be the best way to do it, but we'll see if it comes out to my... Okay, that didn't do it. I'm going to go ahead and I'm going to take the clock out. I'm going to take one of our actors out. Inside of our actor, we're going to display the text. We'll do this 20 times. We'll just have this be a single time through. So for 20 seconds, we're going to go ahead and have this guy's position change and then print out his position. But we just have one actor doing this. What I want to come up with is what his final number is. I'm checking whether they've improved the random number generation for Game Salad. So at the end of this, we'll have a number. Then I'm going to run it one more time. And we're going to see if we get the same number. So, okay, so we got 204. All right, so now we'll run it again. This falls into understanding how we can play within the matrix. Okay, that's actually a good thing. All right, so it appears that the random number generator is actually better than it used to be. An issue we would have had last year, at the very least 2 years ago, but it's possible last year it was fixed as well, is when we had something that was doing something, like in this case, I only have one thread. That's why I took the other actor out, so we didn't have two different timers competing with each other. So I have a single timer that's doing something 20 times. It's generating a random number. What we would have seen with a weaker random number generator is it would have always given us the same stream of random numbers. So we would have always not just ended up with a 204. We would have ended up with all the numbers in between 20 and 204, or whatever my starting point was, whatever it was. Between that and 204 would have always been the same in a row. So it's very difficult then to write video games that have a level of randomness to it if randomness really isn't random. And it's actually an interesting concept in computer science. Sources of randomness. So think about this in real life. If you want something to randomly happen, what's a common thing we do in real life? We flip a coin, right? So what's the idea? The idea is that it's supposed to be heads 50% of the time, tails the other 50% of the time. Mm-hmm. Is that true? I think there's actually some science behind it. The weight of one of the sides is a little bit more than the weight of the other one, and actually it comes, I think it might be heads is the more common. Is that true? Yeah, something like that. But then, that's if you're doing it inside of a vacuum. Then you got to deal with wind resistance and how high it was when you threw it, and what kind of angles you put on it when you toss it in the air. So, there's all sorts of variables. Now, given that, when you start throwing in all those variables, now, is it a better source of randomness than it would be in a vacuum? Probably. Because now, the human being's not going to flip it the same way 2 times in a row, so we're actually using that one side's a little heavier than the other side type thing to even add a little more randomness to it. And then the wind conditions not always the same and stuff like that. Actually, I found that kind of interesting with the Olympics. My wife and I were watching the ski jump. And before each run, they have a point. I guess they have some sort of sensors for wind and things like that. So they adjust whatever the final score of this guy is going to be based on the exact conditions of whatever at the moment he took off. So he might get plus 3 points or something like that on his final score based on the wind being a little bit more into his face than it was for the previous guy. Or, it's kind of fascinating, but I wonder how accurate it is. Like, I wonder if it's scientifically better that way, or if the sport is better to just it's like luck of the draw. You get the gale force winds. I mean, that's the way it works in golf. If a guy hits a shot, then the next guy hits a shot, and there's a gust of wind when his ball's in the air. They don't give him a redo. That's why a real sport is golf. You don't think golf's a sport?
Never said that.
Golf's a sport.
What was I talking about? Oh, sources of randomness. So actually, there's a whole area of computer science that deals with randomness. Having true sources of randomness is quite rare. So when we think about writing video games and things like this that really rely on things not to be predictable, it becomes difficult because we really need to think how random is something. I mean, you've probably all done this before. You've played a video game and you've recognized a pattern that occurs. You know what I'm saying? And even if it's not exact, you kind of know that, for instance, maybe there's a spawn point for a monster or something like that. And you know that every 14 spawns, the guy you're looking for shows up or something like this. So this was an example back from an older game called EverQuest. Okay, EverQuest was one of the early MMO style games. And you used to have people would like basically they wanted to farm this monster for 10 hours. It was really like that. That's why they called it Evercrack. So you'd farm this monster for like 10 hours so you'd have a camp. So when you entered a zone, somebody would yell over general chat, camp check, and somebody say, I'm in Northwest, so that means you couldn't go to Northwest and that kind of stuff. But in any case, you would sit there and you knew that you knew the randomness on the timers in such a way that you only had, in order to, as a single person, farm a camp, you had to somehow get all the guys killed, but get them killed in a certain order, such that the respawn rate made it so that you only fought one guy at a time after you broke the camp the first time. See what I'm saying? So you kind of learn the pattern. I got to kill this guy first, then this guy, then this guy. So you built into it was a level of randomness that wasn't truly random. Okay, so sources of randomness are actually very, very, very difficult. We could teach an entire class on randomness. And there's an interesting paper I often have some of our upper division students write dealing with randomness. Find a true source of randomness and argue why it is a true source of randomness. So just think about that for a second. What are things that you think would be true sources of randomness? And then the question is it truly random? So what would you say if you're going to come up with a true source of randomness? Just to kind of get you started, a good example might be sometimes when you're generating a password. There's some computer programs that'll do this for encrypting your hard drive. What they do is they give you a box and they have you just drag your mouse around a bunch to generate data, right? And while you're doing that, that's supposed to be random data. So the question is that really random? Or is there a pattern that human beings will they'll fall into for dragging that mouse around? I don't necessarily know the exact answer, but the second you think something's very random, you can then come up with some reasons why it might not be as random as you think. Kind of see what I'm saying? So randomness kind of becomes an interesting thing. So anybody have a decent example of what they think might be a good source of randomness? Go ahead.
I don't know about the construction of dice, but that would be the best example I can think of right now.
Okay. So you're talking about like 6-sided die, 20-sided die. Okay. How is that dissimilar from a flipping a quarter?
I think that, as far as I know, they're all weighted evenly.
Okay.
But there is
hence the thing that people have loaded dice, right?
Yes.
Okay.
But there is a limited selection of numbers, so technically it's probably not truly random. You can't go anywhere on the scale if you only have 6 or.
Yep. So I think the thing is with dice. So assuming that it's manufactured to some level of precision, because at what point is it weighted? At what point do we say it's actually really weighted evenly? Is it within a certain threshold? You see what I'm saying?
Yeah.
So then they do most of these tests inside of a vacuum. So inside of a vacuum, it does become a fairly true, it drops it from a certain angle over and over and over again. I think it drops it so it lands corner down. I think it's usually how they do it. So there's a bounce. And then it does have a amount of randomness associated with it in a vacuum. Well, now when you're throwing it from different heights and things like that, then you add your own randomness into it. So, what's your gut feeling? Is a 6-sided die more random than a quarter?
Well, it should be because there's more options.
Yeah, my gut feeling is it is. It's a better source of randomness than a quarter. but it might not be a perfect source of randomness, or even a very good source of randomness. Yet entire games are built around this, right?
Playing a game of chance, isn't it?
Well, so how random is something like, how many of you have ever played a tabletop role-playing game like Dungeons & Dragons or something like that? You never forced yourself into that experience? Oh, you'll never appreciate games like World of Warcraft unless you've done it the old school way. The 48 hours straight epic adventure.
Kind of like Risk.
Huh?
Risk.
Oh, Risk is.
Oh, Risk. Dungeons and Dragons should never be compared to Risk.
Risk is good fun.
That's like the Hello Kitty commercials compared to Game of Thrones. Well, I've been watching Game of Thrones. I'm on episode 5 now. I wasn't really sold on it until the one guy decapitated a horse. Yeah. That. How upset do you have to be over losing a jousting match to decapitate your horse? But now he's my new favorite character. I mean, I would just disclaimer. If I knew the horse had actually been killed, I would be upset by it. But the fact that I'm positive no animals were harmed, kind of like the fact that he decapitated his horse. That's my disclaimer. I was cackling. Which upset my wife, actually. she left the room. That was the first episode she saw.
Oh, that's great.
Because there was a half-hour break between the Golf Channel coverage of the golf tournament and when they picked it up on network.
Ah.
So I had to have something to do for 30 minutes.
The Olympics?
No, who watches the Olympics?
Usually it's the only thing on. And there ain't much else.
No. I'm almost obsessed with curling. I don't know. Like, it's not even the sport, it's the people that make fun of
Obsessed with curling. Did you know there's a local curling league in Mequon?
I don't understand that.
It's not even a sport.
Yeah,
it's the people that make fun
There
of it.
there is a curling venue within 5 minutes of where we are right now.
Huh.
What's the point of it? Yeah, let's throw a
To
round.
watch
something
people
every
be,
day.
to watch how interesting.
No, it's not just that. Curling is a
Shuffleboard of it. Yeah. Essentially.
Bingo.
well, with the exception that the competitors, after you hit a certain point, the competition can then try to get your the
Block or whatever.
the blocky thing to go farther or not go as far as the team that had thrown it intended. So it actually becomes kind of interesting that within a single turn, both teams get to participate, as opposed to it being, one team throwing to try to knock other people out of the way. They get to do their little brushy thing to make it, I guess that smooths the ice so it goes a little farther or something like that. I don't get it, but it's fairly, I mean, apparently there's a lot of complexity to it. It's kind of interesting. But I like the extreme sports far more, like the quad luge. Oh, love that. Did you guys watch that? He didn't even say it creepily. It just came off creepy. It's like, I watch women's luge. Yeah, it's like some of these things are just made up. So luge is you're laying face up on this like tiny little sled. So who decided, well, let's just stack more people on top and fly down here at 90 miles an hour? And why don't they have double skeleton? See, skeleton's fun because when they start losing control, you could just see the dude freaking out. I saw that in the doubles luge. Like this one group they totally lost control halfway through the track. I mean, like they were no longer even coming close to steering. And the dude on the bottom is waving his arms one way, and the dude on top was flailing another way. They made it down. I think they might have even medaled. It's like one of those things that they were so out of control they were fast. It's like I don't even know what happened. I blacked out halfway down. Both competitors crossed the finish line unconscious. Good enough for the bronze. Then it gets into some argument as to whether or not the athletes even make a difference. Like they were not conscious for half of the run. What was I talking? Oh, sources of randomness. So anyways, sources of randomness, kind of a cool thing. Hello.
You drag it to the top in the middle somewhere. Oh, I know. It's dead. All the way down.
Tell me when to stop.
The lid.
Over.
Yeah, randomness. KK, thanks. We're good. All right. So, interesting question. Any of you ever played EverQuest? Or is that
Heard the name.
way before? What year was EverQuest? I played it in
19 anything. We were all babies.
19 anything. I want to say I was playing EverQuest in 98,
I'd have been 5 years old.
That's about.
97.
That was 3.
3 or 4.
All right. So, let's get back to here. So anyways, it seems like our random generator for game style is at least decent. Okay? Not completely useless like it would have been a couple of years ago when you always got the same stream of random numbers. Okay, so let's do a couple of things here. I'm going to go ahead, what did I do? I'm going to create another actor. And we're going to mess around with velocity. Okay, making things move around on the screen. So we're going to change this guy's velocity. In an initial direction, let's just make it 0. So you can do this through you can type in the number, or you can use the little knob here, but it's not very accurate. But if you hit, I think it's Shift. Yeah, Shift and do the knob. It lets you do the 4590, you know, the... So,
I have that in the Windows environment.
Are you lying? Really?
It's really lame.
That actually surprised me. The Windows one's significantly newer than the Mac one.
It seems like
Like
a lot
many
less
years newer.
refined. It doesn't seem as easy to work with.
Hmm.
Yeah, the interface is a little more tricky.
One more reason to get a Mac. Actually, my argument is for all technology students that the correct machine to get as a technology student is a Mac. Not because Macs are necessarily better, but you get 2 machines for 1.7 times the cost. Because a Mac can run Windows or the Mac OS, so you have one machine that can run any software you might ever want. So it's only expensive if you look at it as being one machine, you don't need it for both things. Otherwise, if you need 2 machines, you might as well pay 1.7 times instead of 2.
Or you sacrifice 2 years, you got a breakfast and go for $700.
No, you could do that too.
Or you just deal with the Windows crap.
But then sometimes there's technologies you can't even take advantage of.
Yeah, that's
So, for example, in our program here, we teach a couple of iPhone programming classes.
Mhm.
And those require a Mac. There isn't an equivalent technology to it. Now, we have the nice Mac lab down there that you can come in in the middle of the night and work on your homework. But who likes coming into the lab to do their homework, right?
I have a choice.
What do you mean? You can sell plasma, save up for a Mac. In fact, you might even be able to keep up with a MacBook Pro's monthly payment through Apple through plasma donations.
Isn't it like 75 or what is it? Like
just get lucky.
So you
What, for plasma?
part of your organs, basically.
It's like pretty good.
25 a pop, I think.
And I think you can go either once or twice a week.
Yeah. So $50 a week. Would be nice. Really?
Yeah.
I'd rather.
I've paid for my Mac through a blood debt.
Sold Apple.
No, you just sold everything else.
You become a plasma junkie. You're like going to these different things so they don't know you've already donated this week. You're just like not healthy. I'm running on fumes here.
Sold
All right.
plasma for Flappy Bird.
So in any case, we're going to change our velocity on this new guy. We're just going to have him go directly to the right. And there's a couple things here. We can say go directly to the right relative to the actor or relative to the scene. We'll play around with some of those things. And we're going to have him initially moving at a speed of 300. And we'll see what that looks like. So that's this actor 2. Go ahead and run this, and we see him zip across the screen. Okay. He was still going.
Is there a way to make him reset back?
We can. Actually, we can do it. Is it the scene we can make wrap?
Scene inspectors tab.
It's the scene.
Here, so we can wrap on X, and now he'll just keep zipping it back around.
Oh.
Okay, now he's at a constant velocity, correct?
Mm-hmm.
Okay, so he's just moving at 300. So at this point, we're not really taking advantage of any physics other than we just got the guy moving. Okay, so let's go back into our actor 2. Let's look at the behaviors. We have something called accelerate. Let's look at accelerate. We'll accelerate in the direction right relative to the actor at a rate of 100. Okay, so this is a cumulative behavior. Now, what I've done here, I know some of you aren't going to be able to see this. What you got to do is you got to really pay attention to the center. And it's one of those stereograph things. And if you focus on it and then you try to blur your vision and bring it back into normal vision, you'll actually see a unicorn. I encourage you to do this for 15 to 20 minutes every night. All right.
Slow down. It slowed down and then put back up.
Did it? Probably because we interfered with the thread by moving this thing around. Okay, so now we have constant acceleration until it hits some sort of probably limit size of integer or something like that. Okay, so acceleration is different than velocity. Okay, acceleration is a cumulative, whereas setting a velocity is a one and done. This guy is 300 forever. Make sense? Now, what if we want him to slow down? Let's look at some of our other things here. Okay. They didn't add anything new. I was just seeing if they had. So we are now going in a constant direction to the right, and we want him to slow down. What are things that we can do to make him slow down? Well, let's look at our individual actors. So this is inside the actor, and there's a tab in here called physics. All right. So a bunch of things in here. We have density, friction, bounciness, rotation, whether or not it's movable, its collision shape, its drag. So what happens when we change its drag to 1? Is it slowing down?
Mm-hmm.
Is it actually slowing down? Or is it going at a constant rate that's just slower than 300? So think of this like this guy's going across the screen with a parachute dragging behind him. Okay? What if we increase that drag? How about to 8? So he started off at his full speed, and then the drag caught up with him. So drag is actually a cumulative effect until it slowed down the acceleration to the point, well, slowed down the velocity to a fixed point. So is he actually going to stop? See? Does have a cumulative effect. Make sense? We can just see it more as we increase the drag. All right. So that's how drag works. Okay. What about density? Let's set the density to 5. Any difference? Shouldn't see anything. Okay. What is density? In the real world, what is density? Go ahead.
How much mass an object contains?
Okay. Could we think of density as kind of how fat something is? The effect gravity might have on that something? That makes sense? But right now, we don't have gravity. We don't have gravity enabled in our scene. But if we did, something that's denser is going to drop quicker until it hits terminal velocity. Right? But initially, if you drop a ping pong ball and you drop a bowling ball, eventually they'll hit the same speed. After, like if you threw them out of an airplane and you take wind resistance out of it and all that stuff in a vacuum again, they'll hit the same speed. But initially, the bowling ball is going to accelerate quicker because of its mass. Okay, so that's where density plays in, and we'll mess around with that as well. Bounciness, we're not going to be able to show you this yet, but this is how much it bounces off of other things when we mess with collisions.
Is that supposed to be a scientific term?
Which, bounciness?
Yeah.
Yeah, it's completely scientific.
Right.
It's part of a Newtonian something or other. Newtonian something or other. Fixed rotation, this will also be a collision-based thing. Whether or not something's movable, we're accelerating something that cannot be moved. Or setting the velocity of something that cannot be moved, so as you see, it's not moving. That's what movable means. Collision shape, again, this will make sense when we deal with things colliding into other things. We have two choices, rectangle and circle. Rectangle means you actually have a square, a rectangular box around your actor. And anything that collides with any of the sides of that box, it'll be treated as a collision. Circle means it'll be a circle shape. So think of like Mario. You know how if you're playing Super Mario Brothers, sometimes he'll jump on something and pixels seem to have collided, but you didn't actually hit the thing? He probably has a circular impact box inside him. So even though his foot technically hit the little turtle guy, it was moving along the curve of that circle, so it was not a collision. Make sense? So those are our two choices for that. We already messed with drag.
Definitely Flappy Bird.
What's up?
Flappy Bird's definitely a circle.
Yep. Actually, it might not be.
It might be.
It might be a square to make it more difficult.
Yeah.
And I can see him like actually extending it out, so it's like bigger, and then it just makes it mind-numbing. Like, look, I did not hit it. It's like, no, you totally did. It's like, how did I hit the one over there when I wasn't even through this one here? Because the box takes up 2/3 of the screen. Okay, so now we're under motion. So within motion, we have some fixed motion things. We have something called velocity, not to be confused with acceleration. Velocity is how fast we are going on an individual axis right now. Make sense? Okay, so velocity on X, positive velocity means we're going to the right. You're my left, your right. Get it? All right, so in any case, negative velocity means we'd be going to the left. Y positive is up, I believe. Negative is down. Don't quote me on that. Angular velocity, we can also set the max speed of something. Okay, so that's what motion is in here. Graphics, whether or not something is visible. Blending mode, this is how it interacts with other things in the scene. Horizontal wrap, we can decide how we want this to act, assuming horizontal wrap is turned on for the scene, how we want this guy to actually work within that. We'll mess around with those things. Vertical wrap, horizontal anchor. We can choose him to flip horizontally or flip vertically. This actually becomes helpful when you have something go this side and then this side. Go back. Otherwise, he's just like doing the moonwalk backwards. You might want to have him flip over so it looks like he's still facing the right way. Okay, so that's our graphics. Okay, so that's what we can do at the actor level. Now, let's go back into our, well, let's look at game first. So for our game, we have some attributes. We have the name of it. We can set a time. We pick our display size. That is the size of, I believe display size is the size of this white box in the middle. Well, not this one, but you get what I'm saying. So anything outside of here, like this guy is half on the screen, half not on the screen right now. Okay. And then this thing is for if we want to actually test it on a real device, and we'll mess with that. But let's go to the scene, because the scene becomes more interesting. We can control physics at the scene level. So again, we have whether it wraps on the X and wraps on the Y. Then we have a drop down called gravity. How hard do we want gravity to push? So let's say gravity on Y is 20. Again, gravity has a cumulative effect, right? Just like on Earth, if we didn't have the ground, we would just keep falling until we, at some point, I guess you maybe exit the atmosphere on the other side, or bad things would happen eventually. I promise you. Actually, gravity would flip. Once you hit the core of Earth, gravity would flip.
Bounce you back.
So then you just stay in the core.
You might, but I don't think you'd make it that long in the core.
You'd be dead.
Yeah. Did you ever see that movie, The Core?
Yes.
That was a good movie, wasn't it?
Like,
Like, shockingly good movie. Like, it seemed like it was going to be a stupid movie.
I didn't get to finish it.
What was the name of the metal? That could be a quiz question. Unobtainium. The hotter it gets, and the more pressure on it, the stronger it gets.
I got to where they were digging in it, and the freaking projector at the theater broke. We had to leave.
All right, so let's just, in our last minute here, let's just look at a couple other things. So again, under scene, we can set the gravity, we can set the color, we can also set where the camera is on the screen. The origin of the camera, its size in terms of how big of an area the camera is focusing on, as well as the tracking area. And we can also mess around with auto rotate. Whether it your game, when you turn it from left to right on a mobile device, whether it should update for the right now it's locked into landscape left. So you have to hold your video game, you have to hold your device a single way. Okay, so what we're going to do next time, because I like golf, we're actually going to create an interesting application, messing around with physics. We're going to create something that allows somebody to mess around with, it's like a golf launch monitor. So we're going to be able to set some variables for the launch angle of our golf ball. So this is like if you're hitting a driver. The launch angle of the golf ball, the speed of the ball at launch, and the distance it will travel as gravity has the effect on it. That make sense? So the idea is that we're putting these different variables in here as if we just hit a golf ball with a driver and we want to know how far will that ball go, again under conditions of a vacuum. How far will that ball go with no wind resistance or anything like that, given the effect of gravity and your launch angle and the speed it was traveling initially. Make sense? Okay, so we'll come back, we'll look at that on Wednesday. Well, we'll start looking at that on Wednesday.